Hi guys, and welcome back. So in the last couple of videos, we took a look at a couple of different scenarios where our Kubernetes cluster would be kind of out of service or at least partially degraded, and we took a look at how to fix those. Now, something else that you can run into on a Kubernetes cluster, this certainly isn't a comprehensive skill. We're not going to cover all 100 or 200 or 500 different use cases where your services may be degraded or your cluster may be misconfigured and things like that. But one of the other things I wanted to come and demonstrate to you is what happens if your cluster gets overloaded. And so what can happen here is you have an EKS cluster and you've got your master nodes that are opaque. You don't have access to those. Then you've got your worker nodes down here that are actually running your application. And these worker nodes, if you don't have enough capacity, can actually get overloaded. So the scheduler that's running on the master nodes can basically schedule too many pods to run on your worker nodes and consume all of the system resources that are available. And if you don't have cluster autoscaling configured, then your cluster is not going to add in the necessary capacity to run those pods. So what we're going to do is basically just take a quick look at how that scenario would play out. So for starters, I'm going to just fire up a VS Code window here, and I'm going to go ahead and create a new file, and we'll set the language to YAML here. And I've got an extension installed for Kubernetes that allows me to get pre-built templates. So I'm just going to go ahead and plug in a deployment manifest here. And this deployment manifest, this is a deployment controller that is basically going to allow me to spin up pods on my cluster. And I can set a property down here called replicas. So if I set the replicas property on the pod spec down here, actually I think I need to put it at the deployment spec level right here. So let me just confirm that. Yep, there's replicas. So what I can do is basically say, all right, I'm going to start out with 5 pods, and then I can scale this deployment controller up and say, well, actually I want 30 pods. And if the deployment controller that's running on the master nodes decides that it wants to try to schedule 30 pods onto, only 2 relatively small size worker nodes, then those worker nodes may not have enough CPU and memory to satisfy the needs of all 30 pods. And so that can create resource constraints, which will result in pods not actually getting scheduled onto the worker nodes. All right, so let's go ahead and set some metadata here. I'm going to call this my web app, just as the name of the deployment controller. And then for the selector down here, I'm going to go ahead and just say app is my web app as well. And I'll just copy that into the templates labels as well as the name of the container. Or actually, we could just call this like Nginx, for example. And then for the image here, I'm going to choose just an Nginx base image. We're not going to actually run any seriously heavy compute workloads here. However, what we are going to do is go into this resources section, and instead of setting limits on the resources that the pods can consume, we're actually going to change that over to this requests property instead. And when you use the requests property, what you're essentially doing is telling Kubernetes that you want each pod to have a minimum amount of compute resources. So what that's going to do is allow us to say, all right, I'm going to allocate maybe a single CPU core to each pod and maybe 2 gigabytes of memory to each pod, or maybe 1 gigabyte of memory. And by doing that, we can essentially force the pods to request a certain amount of system resources and intentionally starve our cluster for resources. So I'm going to change this container port to 80. And what else do I need to set here? So let's go ahead and set this resources section. So I'll change limits to requests instead. And these squiggly lines are going to be here because it's complaining that I don't have a limit set. So if I go over to problems here, you can see it says no resource limits. So it's a good practice to put limits on your pods so that they don't, kind of blow up and start consuming tons of system resources that they shouldn't be. However, in this case, we're just going to leave limits out and we're going to be using requests instead. And so for the memory, what I'm going to do is say I want every single pod to have, let's say, 1024 megabytes of memory. And for CPU shares here, I'm going to say I want each pod to take 500 millishares of CPU. And so that basically translates into half of a CPU core. And once I've got this deployment controller created, I'm going to start out with, like, let's say 3 pods, because we should have enough capacity to run at least 3 pods. I think the M5 large has 2 CPU cores and 4 or 8 gigabytes of RAM. I don't remember exactly how much it is. Let's head over to AWS here and look for M5 large instance. Just see how many system resources each of these has. Go into the instance types here, go into the M5, and M5 large has 2 vCPUs cores and 8 gigabytes of memory. So essentially, if we spin up more than approximately 16 gigs of pods, then that's going to starve it for memory. And if we exceed at 500 millishares, half of a virtual CPU, so on each node that has 2 CPU cores, we'll essentially be able to fit about 4 pods approximately. And that's not counting the overhead of the system itself, the operating system that's running, and any other components. We're purely talking from kind of the pod scheduling perspective here. So over here, I'm going to say, let's start with 3. And so that'll consume about 3 gigs of RAM. Actually, let's change it to 4. So that'll consume 4 gigs of RAM, well under the 16 gigs total that we have across the 2 nodes. And then it should be taking up, let's see, 2 full virtual CPUs. So between the 2 nodes, we have 4 vCPUs. And so if we do 4 times 500 millishares, that'll give us basically 2 CPU cores that are going to be consumed. So we'll start off with that and then go from there. So in my PowerShell window here, I'm just going to go ahead and paste in this deployment text as a here string, and then I'm going to pipe it into kubectl apply -- file name -- and I'm also going to specify the namespace of default so that those pods get scheduled in the default namespace on the cluster. All right, so we've created our deployment controller, and I'm going to do a kubectl get namespace, get ns for short. And as you can see, I've got the default namespace right here. So let's do kubens default. And if you don't have kubens installed, that's just a nice open source utility that allows you to change your active namespace very easily. And now if I do kubectl get all, that should show me pods, services, deployment controllers, replica sets, all that kind of fun stuff that you typically have on a Kubernetes cluster. And as you can see, we've got a service here. I created that a while ago. It's just kind of an orphaned resource that I don't really need. But right here, I've got my deployment controller. This is basically asking for 4 pods from the pod spec that we defined as part of that deployment. And then down here, it created a replica set, and the replica set asked for 4 pods, and it says that 4 pods are in the ready state. So as you can see right up here, these 4 pods that were just created are up and running. They're in the ready state. And so these are all healthy. So at this point, if we were to scale up beyond the system resources available in our cluster, let's find out what happens. Now, we don't have to manually edit the YAML here for the deployment and then go back and paste it into the console again. We can actually use the kubectl scale command. So let's do scale. And what we can do is say scale and set a deployment controller with a particular name to a certain number of replicas. So let's do kubectl and then scale. And then we'll do deployment / my web app, because that's the name of our deployment controller right up here. And then we'll set replicas equal to, how about, let's do 16. So that should easily starve our cluster here. All right, so that's been scaled, and now we'll do another kubectl get all and see what we get back here. So instead of just the 4 pods that we had in the running healthy state, wow, check out what we got here. So our deployment controller has requested 16 pods, and the replica set has been updated by the deployment controller to request 16 pods. However, check it out. The replica set only has 6 pods in the ready state, right? So we asked for 16, and technically it actually created 16 pods. However, only 6 of them are in the ready state. Check out what's happening with these other 10 pods here. Well, most of these pods are actually just sitting in the pending state. So if I run this command again, just to confirm that no additional pods have been spun up, let's see what we get back after a couple of seconds. Usually these scale like almost instantaneously, but sometimes it might take a second or two for it to scale. And no, sure enough, we still have 10 pods just sitting right here in the pending state. So what you can do is basically grab one of these pod names, and then we can do a kubectl describe on that pod name. And as you can see right here, it's actually giving us a message or an event called failed scheduling. And that event is indicating that there are 2 insufficient CPU nodes. So 0 out of 2 nodes are available because both nodes have insufficient CPU capacity on them. So basically, because we have 6 pods that are each requesting 500 millishares, that's 3 full vCPUs, and the system overhead is probably consuming the other 1 vCPU that we have kind of aggregated across both nodes, and so therefore there is no extra capacity to run all of these nodes. So the solution to kind of handle this is either to scale the application down, so we could do a kubectl scale and then set this down to 6, and we know that 6 are healthy, so we at least have enough capacity for 6. And then if we do another get all here, we should see that those 10 extra pods have been eliminated from the cluster, and we should just be left with 6 in the running state. So sure enough, there we go. So now we're no longer experiencing an error because we're not requesting more than what we have. The other option to fix this is to add additional compute nodes. And one way to do that in AWS EKS is to use EKS CTL to create a node group. So you can create additional node groups and join those to the cluster, or you can actually scale the auto-scaling group that was created for the first node group that we have in our cluster. So if you head over to AWS or your cloud vendor's implementation of this feature, you'd go down to auto-scaling groups, and you would find the auto-scaling group that's associated with your EKS cluster. And you can see that if we go to instances right here, it's currently set to 2 instances, and it has a maximum of 2 instances. So it's never going to scale above or below 2 instances. However, we could actually edit this and increase the maximum capacity to say, I want up to 6, and then we could change the current desired capacity to maybe 4 nodes, and then we could update that. And the auto-scaling feature in AWS, or if you're using Microsoft Azure, I believe they have something called VM scale sets that would basically do virtually the same thing for you. It would automatically scale up your nodes. And then if you come back to instances here, you should see in a moment that a couple of new instances have been added. So we've got more virtual machine capacity. Now we have 4 nodes in the running state here, whereas previously we only had 2. And so then we can come back to the terminal here, and we could scale back up to 16 replicas, and we probably still won't have enough for 16 because we only doubled our capacity, so we could go from 6 maybe to 12. We'll still probably have trouble replicating up to 16, but we'll have a lot more capacity than just 6. So if I do kubectl get node, eventually after a couple of minutes here, you'll see 2 nodes join the cluster along with our 2 initial nodes that we have here, and then those additional pods can get scheduled onto those new nodes. I hope this has been informative for you, and I'd like to thank you for viewing.